This isn't some small decision you can just fix later on. The choices you're making on day one, right now, they have massive financial and operational consequences down the line. Getting this right from the very start is absolutely 100% non-negotiable.
So you might be asking, why even take on this challenge in the first place? Well, it all boils down to a core philosophy. When you self-host, you're not just renting a tool, you're taking ownership of your own infrastructure. And that means you control your margins, you own your data, and you gain the ultimate power to scale on your own terms. This mindset, this is the foundation for everything that's going to follow.
And it's so crucial to understand this mindset shift. For a technical founder who's building an event-driven business, your automation platform is not just another monthly subscription. Come on, it's the central nervous system of your company. It's the operating system that handles everything from billing events to data enrichment. You have to treat it with that level of respect.
Okay, now for the first trial of the gauntlet. And honestly, this is the most common failure point for new deployments, the database. This is where so many setups fall apart, and a simple oversight here can bring your entire operation to a screeching halt.
Right out of the box, most self-hosted setups come with the default SQLite database. And look, it's great for testing, for playing around on your local machine, but in a live production environment, it is a ticking time bomb. It's dangerously insufficient. It's not a matter of if it will fail under real-world traffic, it's a matter of when.
Let me paint you a picture. You just launched a huge marketing campaign. It's a massive success. But suddenly, 50 webhooks from your form submissions hit your server at the exact same time. This moment of triumph, this amazing success, can instantly turn into a catastrophic system failure if you're using the wrong database. And here's exactly what that failure looks like under the hood. That traffic spike creates a flood of simultaneous write attempts. Now, since SQLite is just a single flat file database, it simply locks up. It can only handle one write at a time. The other writes fail, those webhooks are lost forever, and this is the worst part. There's no warning. Your automation just silently stops working.
So the fix here, the crucial point is this. You absolutely must upgrade. SQLite is for testing. Period. End of story. For any kind of production environment, a dedicated PostgreSQL container is the mandatory choice. Postgres is built from the ground up to handle massive, multi-threaded, concurrent traffic. It's how you bulletproof your system against those critical traffic spikes.
All right, so with our database solidified, it's time for the second trial, securing the gates. We need to build the fortress walls by correctly configuring how our system actually talks to the outside world. This is all about the networking layer. You know, if you just expose your automation server directly to the internet, you've got two huge problems. First, it's a massive security risk. You're just leaving the front door wide open. Second, it's just not going to work. Modern platforms like Stripe or GitHub will actively block any unencrypted HTTP traffic, which means your webhook endpoints are completely useless right from the get-go. The solution to this is a reverse proxy. Just think of it like the essential security guard for your entire operation. It stands at the gate, it intercepts every single request coming in, it handles all the complex encryption, and only then does it securely route that validated traffic to your core application. So here's how that secure flow actually works. Your domain points to the server, right? But the reverse proxy is the first thing any traffic hits. It automatically handles the SSL certificate, wrapping everything in secure HTTPS. And then it passes the encrypted data internally to the right container. And this means your core application is never, ever directly exposed to the wild, wild west of the internet.
Okay, so you've passed the first two trials. Your database is rock solid and your network is secure. But now you face the third challenge, which is really a good problem to have, but it's a problem nonetheless. What happens when your traffic grows so much that it completely exceeds the limits of a single machine?
As you scale up to thousands of webhooks per minute, that all-in-one single container model starts to break down. It hits a major processing bottleneck because it's trying to do everything at once. It's trying to catch the webhook, process the data, and run the logic all in one place. At scale, this monolithic approach will inevitably fail you. To solve this, we introduce a new piece of amazing technology, Redis. You should think of Redis as a high-speed air traffic controller for all your workflows. It's an in-memory message broker that lets you decouple your architecture, transforming your single instance into a distributed, incredibly scalable system. And this, right here, This is the exact blueprint used by billion-dollar tech companies. You split up the work. The main instance is just for you, for editing. Then you have lightweight webhook processors that do nothing but catch data and throw it into the Redis queue. And then a whole fleet of worker nodes pulls jobs from that queue and does all the heavy lifting. So if you get a traffic spike, you just spin up more worker nodes. It's pretty much infinitely scalable.
So, we've made it through the gauntlet. We've tackled a database, the network, and the really tough scaling challenges. Now, let's bring it all together into one final actionable checklist. Your blueprint for a truly bulletproof system. This right here is the key takeaway. This simple table separates a fragile amateur setup from a true enterprise-ready system. For your database, the risk is silent failure. The solution is PostgreSQL. For networking, it's insecure traffic. The solution is a reverse proxy. And to handle scaling, you avoid that bottleneck with Redis and distributed workers. It's that simple.
And that brings us to the final question you need to ask yourself. Look at your own systems, or maybe the ones you're planning to build. After everything we've just covered, be honest. Are you building a ticking time bomb, or are you engineering a fortress? The choice is yours.